Hey, so last time we have created this experience that you see on the screen, and we set up some BabylonJS code here in this TypeScript editor component. We copied some parts of it from BabylonJS documentation from the playground, and we also made it so that it responds to things that we provide through inputs, like the radius of the circle. We can adapt that here by dragging this number slider. We can also tell it to have fewer subdivisions or more subdivisions, whatever you prefer, right? We were able to inspect these particles in 3D, so you can use rotations and zooms to check how the particles look like. And yeah, we also made it possible to change the colors, adapt all kinds of things with this script, right? So it's not very long script, but it does involve some more advanced things in TypeScript. And in this tutorial, we will go further and we will create camera paths that we will be animating. So basically, when you want to, skip this mode of rotation that you have here, you may want to automate how your camera moves in the scene, so you could prepare better looking animations for your videos, for example. And this is what we will do. So we will be creating a path through which the camera will move around this particle system, and we will be using control flow. Control flow is one of the latest additions to Rete editor. It's still a little bit experimental, but it does work. So we will be using its features to automate the camera paths. And yeah, let's get started. So I will just return the colors back to purple. I like those more. And also I will just make fewer of those systems so they don't, show up too much in this canvas that we're creating. I do like that they are there in the background to just remind myself that it's still running and working. Okay, so now let's create that path, right? Let's use JSON code editor that we also introduced recently, and let's create 4 points in it. So to do that, we go here, we create an array that is inside the other array, and we just define the coordinates. So we want to go from 0, 10, like this one. And this will be 1 point, right? We need 4 more. This is at least what I want to do. And let's create those. Let's change these values to give us 4 points on different corners of the camera path movement. And also let's put every second point on 10, like this one. Let's hit run this code, and you will see 4 points appear in the space. So we have this one, and here the other one. I will also use draw grid mesh to just give us the ground so we can visualize it even better. And what I will do is I will just create a wire, so polygon wire in this case, and this will just create a polygon through those points. Another thing that I want to do, because this polygon is having some sharp corners, I want to fillet 3D wire like this one. And let's do it, and let's use the radius of 5. So you see that now we get a nice looking path. We hide the original path because we don't need it. And so the trick is to subdivide this path into multiple points so that we could move our meshes or cameras through it. So let's do that. Let's subdivide this wire to points, and we need to use this component that will use equal distance. Let's provide that to the shape, and let's also use 100 subdivisions. So now you see that we get all of these points across the path, right? So how the algorithm will work, it will just go through each of those points, it will get its coordinate, and it will place the camera on it. That's quite simple, but to illustrate that, I will just first set up some mesh, and we will set its position to those points so that we can see it from the outside. So we will also do one more thing. We will remove the endpoint from this list, so we end up with nice movement, nice fluid movement for the camera. So let's create a sphere to just give us a good looking object to move across those points. I will also just draw it, and because I want to use a different color for it, I'll use the options, shape simple, these ones. I will not draw the edges. Okay, hide, and let's use maybe something like this one. Okay, so now we have an object that we will be moving across the path, and we will implement now the logic that will allow us to select points from the list each time we click a button. So for that, we will go into this flow category, and we will go into the counters. We will add this counter. We will go to actions, and we will add the trigger into the canvas. So we will be executing this counter that goes from minimum to maximum values by clicking the button. We'll have another button that will also reset the counter if we need that. We will go in steps of 1 so that we select the index that is correct. So if we do that in 0.1, you will not find any points there. Yeah, we have a count from 0 to the max, and the max should be actually the length of this array. So let's do that. Let's use list length component to measure the length of the list. And we also need to subtract, so we will do toNumber operation. We will subtract 1 from this list because we start at 0. It's important to subtract 1 from that length. That is quite important concept, and this will make sure that we don't ask for a point that is not existent in the list, right? Okay, so now that we have this setup, we can also preview the data that we get from this counter, right? So let's do this. You see that if I click the button now, it should execute. We need to plug the execution here. So I click it, and now you see the number change. If I trigger the reset, it will go back to 0. It's also quite cool because if you want to know how it works, let's try this out. Let's put the maximum on 5. And now let's trigger it to go to 5. And now if I click again, you will see that the counter resets to 0 automatically. If I would choose to pulse to have this option enabled, if I trigger it to go to 5, you will see that if I trigger it again, it goes to 4, and it goes to the minimum, and it goes back to the maximum, and so forth. So this is what that option does. And sometimes you need that if you, for example, would like the camera to move to the end of the path and then move backwards, But yeah, in this case, it's not necessary. So let's not use this, and let's bring back, the maximum to be the length of this list. Yeah, okay, so now we have this. And to get the item from the list, so we need to use this list. And we will be getting an item, and this is the component that we need to use. You can find it here as well. So lists, item by index. And we will be taking this list. We will saying that we will be using this counter index in here. And then we also will execute this code each time. And we will not be cloning the list. So now if I preview the data that I get here, so let's do this. You'll see that every time I trigger the button, this coordinate should change, right? Yeah, and it does that. And this is because I'm just selecting different points each time. And while this doesn't have any effect on the scene yet, we will see how it will. So this is quite simple, actually. You go to Babylon, you go to this mesh category, and you find this set position component. And you will now use this result as a mesh, because this is actually Babylon mesh that is being generated, right? And you will use this coordinate that comes from here as a position. So now if I click this button, so I'll trigger it, you see that the sphere moves across the path. This is quite cool. So if I, for example, change the number of subdivisions to something like 20, and I click trigger again, we may also reset the counter. Let's do this. Let's go across this path really fast. You see that it will go in circles because it goes from the maximum to the minimum, and it goes again, you know. So this is quite nice. We have our simulation, right, of the camera movement represented by the sphere in this case. And now we just need to apply the same trick to the camera position. This is maybe not as straightforward as you will imagine, but yeah, it's still quite simple. So first thing that we need to do is we need to create a camera. Let's create the target camera. We use this component for new target camera. Then we need to tell, you know, the scene to activate this camera. So let's use this component from the scene and let's plug it in here. So you see that now it already activated this camera, and the arc rotate camera that we had is disabled. So now you cannot rotate anymore the scene. I will then replace some parts of this code. So what I will do is I will disconnect this execution. I will connect it here. And I will also say that after I trigger, I create new camera, I activate it, and then I start the interval, right? So the interval will make sure that we don't need to click each time the camera position needs to change. And I'll do that. So let's go into the time. I'll create the interval and I'll trigger it every 10 milliseconds. So after I activate the camera, I trigger the interval, and the interval then will execute the counter. So let's do this. Okay, let's execute it. Oh, like this. So let's trigger now this whole camera. You see that the sphere is really moving fast, and that's because, you know, we had only 20 subdivisions for this path. Let's create 1,000 subdivisions. Yeah, now it's good. Now it's rotating, and we just need to hide those points. We don't really need to represent those. So this looks much better. The position is changing smoothly, and the sphere just moves along the path. So this setup is now quite ready. We just need to change the position of the camera instead of the sphere. So let's just, remove this whole script. Let's also remove the sphere. We don't really need that anymore. So now we will go to the cameras, we will go to the target camera, and we will set camera position like this. We'll use our new target camera for the camera input. We'll use the position like this, and we will also make sure that we execute it like this. So now it's moving, but we also need to set the target to look into 0, 0, 0 vector. So to do that, we will say vector XYZ needs to be created here. We need the target like this. We will force this target to execute because the vector doesn't change. This, algorithm may think that it doesn't need to update. And I will also provide the execution from this component. And the camera, again, we need to use that one. Let's plug it in here. And now you see that the camera is moving on the path correctly, and this is looking much better. So if you want to slow down the camera movement, you can just, increase the number of points, for example, to 2000. This will also create for a smoother animation. You can also just play with the timer if you want to, like maybe you want the interval to run, slower. So you could also create screenshots every time the camera moves to a different position, but then you wouldn't use the interval. You would use basically a loop to trigger the event. And we will talk about that in a different tutorial. For this one, I think it's enough. We have achieved what we wanted. This is looking great. You may want to, just hide the path across which you're moving so that it's not disturbing your rendering. And everything is still working as you would expect. You can increase the number of particles. You can maybe increase even the radius size for this whole thing. And this will just adapt. So this gives you a nice looking setup. You can go into the full screen mode and look into animation. I hope you guys enjoyed this video. This was a short one and fast one, maybe a bit intense, but it's just explaining you how you can leverage our CAD algorithms that create paths and how to use those paths for camera movements. I bet there are better ways to do this, but yeah, for now it's this one that I really enjoy using myself in the animations, and I hope you will find that useful. Yeah, let's see each other in the next videos. Cheers!